Okay, so the first law that I'm going to be showing is Boyle's law, and it like explains that when the pressure increases, the volume will decrease. So here I have like the like syringes that you take medicine in, and then I have these gummies, and I put them inside, and when I push on it, the gummies like become smaller, and then when you pull it out, they like expand to like their natural size. So that shows that like when the pressure that I'm putting on it increases, the volume of the gummies is decreasing. But then when I release that pressure, if you look closely, like the gummies got larger back to their natural state. So the volume increased. Okay, the next law I'm going to be explaining is the Charles law. And it's when the temperature increases, the volume also increases. So for this, I'm doing popcorn. So this is what popcorn looks like before it's heated. And then this is what it looks like after it's heated. It gets larger. So it shows like when it gets warmer and hotter, when the temperature is rising, the volume is also increasing in the popcorn. I'm going to be explaining the math for Boyle's law, and I have it all written out right now, but I'm just going to explain it. So pressure 1, we are saying that it was 3 atm, and the initial volume was 5 liters. We are trying to find pressure 2, and we know that the volume increased, and it could be known as 7 liters because when the pressure decreases, the volume is going to increase. So we put these numbers into this equation up here, and we solve that 3 times 5 equals 15, and then we are trying to figure out what P is, so we brought that down with the 7, and then to get P by itself, we divided both sides by 7 to get that the pressure after it was let go was 2.14 atms. One that I'm going to be explaining is Charles' law. So this was the one with the popcorn. So here I have the volume of the popcorn kernel without being popped was 40.8 atm, which I searched up to make sure it was correct. And then I did it room temperature because obviously the popcorn is not heated up yet and it's not cooler than the room temperature. So, which came up to be 293 kelvins. And then the volume afterwards is what we are trying to find, the volume of the popped popcorn. But the temperature that the popcorn comes to be is 453.15 kelvins after it is in the microwave. So I used this equation to find the volume. So the initial volume was 40.8, which is divided by the initial temperature, 293 kelvins. And then that is equal to the volume, which we were trying to find. And then the after temperature, which is 453.15. So we divide these two numbers, which gives us 0.14, which equals still this right here. And we're going to multiply both sides to get the volume by itself by 453.15 on both sides. So the volume is equal to 63.4 atms, which shows that because the temperature rised, so did the volume, which increased the volume of the popcorn before it was popped and after it was popped.